Today we'll be working on Part C of Homework 1 for controls, which has a heated tank with a cross-sectional area of 1 meter square that's drained through a hole at the bottom of area 0.05 meters cubed. So with that, we can look at a tank with a flow coming in and a flow coming out. The system has been operating at steady state with water flowing in at a given amount with a given temperature. And with an applied heating power. So if it's at steady state, and then heat source, then we also have a flow out and a temperature out, which the flow out would be equal to the area of the hole times 2GH, this height being H, and this hole being AH. Then area of that would be the area, cross-sectional area of the tank, and I believe that would be our picture. I'm gonna switch over to a camera to help see a little bit better. Oops, wrong way. There we go. And then now we're gonna need our balances, which we can start with volume, which would be, if we remember dV dt equals area over height dH dt, which is equal to Q in minus Q out, if I remember correctly. And then we know that Qn is, we have, and then we have this equation for Q out. We also know that mass is equal to density times volume, or that's not the same for density. Density is the other way, it's not. There we go. Which for our energy balance, know that this, I believe, one second, we would know that this is a true because we have our heat going in minus the energy from the flow coming in, or flow coming out. Well, one should be in and one should be out. That was my mistake. And then when we look at this, we can cancel out our C's and our rows from both sides. to give us VT over DT equals Q minus QN, TN is Q out, temperature out. So I missed one thing. We know that our T out is just equal to T because our TN minus our TN and T out, because we have a steady state, are going to be the same. And then this V, this volume, I need to change to area dH dt. And then I missed one more thing, which is here. When I divide by that, we can take it out of these two terms, but I need to compensate for the Q. And then lastly, I'm going to move area to the other side. And then, since this looks like a mess, we know that that can be equal to dH dt times T plus dt dt h. And I need to keep all my T's differently, so let me go through and make that change before I get too messed up with everything. And then this, and this should be capital T. Just so that I know which one is which as we move on from here. Okay, so now that we have these two equations, we can find, I'm just going to rewrite them up here. Qn minus Q out, or Qn minus here 2GH is 1, and then the other one we have will be dt over dt which would be Q C times QN or capital T minus this guy 1 over A, and then 1 over H. H. Plus dH dt, I believe. Okay, I did some really terrible math here. My TN is still here. T here is still here. It would be this, plus dH dt times T, all divided by H. Now I think we're good. So we'll need to start by finding our initial height, which I can make this lowercase. All my height should be lowercase, which, since we're finding this, we can use this equation. And then we would have to solve for our height, which I will do momentarily to find this. And then the next thing we're looking for is our initial temperature, which I'm going to run into space on this whiteboard. So, man, my classmates have it nicer not having a whiteboard. But to get here, we know that our change in height is going to be 0. So then this would be equal to A plus minus. Or if I multiply by that would be 0. So the term, so I'd have negative Qn divided by area of the home squared times 1/2g. Still good, right? Yep. So now we need to find the initial temperature, which we'll use this equation here. So I'm just going to kind of draw an arrow. This is what we know based off of it being temperature initial. So over here we're looking for this term, initial term of this. So with that, you know that T naught, or the initial temperature, will be equal to this guy. This term would be 0. So it would be this times 1 over this whole guy. Yeah. Because this term would come to 0, this term would come to 0. Okay, now I have the different setup. The stuff's still on the board back here, but then my second angle. So to start with our code, which I believe you can see, yes, okay, we're good. And I click start, right? Yes. We can go to, we'll do our typical import NumPy as NP. Oh, it's going to really get mad. And then from SciPy, ooh, I don't remember these. I know I want solver IMP. It's SciPy Solver IVP. I just forget how to SciPy.integrate. That's what it does. Integrate, and then it's import. From import solve IVP, and then from plotly that one we're gonna come back to. But then we need all of our things that we have. So we have a cross-sectional area. I know it's bad. 1. We have a bottom hole area of 0.05, both in meters squared. Steady state of water at 1. So we know our Qn is going to be equal to 1. Our starting temperature will be 350 Kelvin. And then we have power, which is at 35 megawatt. Okay. So we have area of the hole, Qn, and then temperature, which this is the initial temperature operating at a steady state of this. But then the third question says the inlet temperature drops to 340. So this is T and not, and then this is Tn, which drops to 340. And then what other variables do we have back here? We have rho, C, and G, which G is 9.81. Rho is 1,000. Wait, we are dealing with water, right? Yeah. 1,000 suffices, and then what was the other one? And then the other one was specific heat, if I remember correctly. Gram and joules, kilogram Kelvin. 4184. Our power of heating, which is 20 million, which is 2 to the 6th. Mega. Yeah, megas to the 6th. Okay. Am I missing anything? think that's everything to start this problem. Area 1 QN that. Okay, so then we can start writing down our equations. Which we have H naught, T naught, no, T naught, and then Q out, naught, which there's another spot to put it. H naught is going to be equal to Qn divided by AH. Squared divided by 2g. This would be equal to AH divided by AH times square root two times G times H naught, oh, caps lock, H naught. And then this guy, this more obnoxious one. Oh wait. Yes. Just Q naught over a P times C times T naught or Tn. Actually, wait. I don't know if this is the equation I want yet. Minus Qn, oh, wrong Q. This is not. It should also be not. Qn not. And dismal. Aha. MP, what? Okay, when we plot, we'll get to plotting. So those are our three equations that we derived on the board. Did this. Kind of. We need to use the integrate solve.ip. Derive expressions for the initial steady state height and temperature, check. So we're just looking here, which I believe I'll need these two here in a second. And then we have a time of 2,000 seconds. So now we can get to our right hand side for coding. So we'll have to define that equation using all the equations that we have here, along with the ones behind us. Define dH dt and dt dt. So the change in height over the change in time, change of height in respect to time, the change of temperature in respect to time. So in order to start that, we have to define, ooh, 1 second, my computer's acting up. There we go, now we should be good. Define a right hand side in terms of time, temperature, and height with all those equations, as I mentioned before. So define right hand side into time and a vector where temperature and height will equal our, can be replaced by vector. And now we have all of our fun equations. I wonder if I can just, I can. Let's make sure that all copied how it should. And then we can also take this one and then I'm going to write the one for Q out from above. We'll take the not out, and then we'll also need the DHDT, which this is going to be a lot of back and forth. It's all over A, but it's Qn minus Q out. I believe Qn minus Q out. And then our other one be equal to, I don't know if this is right. Is this right? Up to here is right. So we want dHdt, and we want dt dt. But this equation, I believe, is wrong based off of what it gave. Makes sense. dt dt is equal to Q over PC rho C plus Qn naught. Qn naught minus Q out divided Q out, and I need this to be multiplied by Tn. temperatures capitalized. There we go. And then this would just be multiplied by T. And that would be all over A would then be minus, subtracted by all over A minus T times dH dt, which would then be all over H. And then we'd want dH dt and dt dt. Right? So we have our equation for Q in respect to time, our Q in respect to time, then Q out, so we have Q in and Q out, because the time will end up equaling 2,000 seconds, if I remember correctly. So we have T. We'll input these values from somewhere, or we'll be solving for them. Can I just pause Grammarly? Does that work? I'll turn off suggestions on Collab. There we go. Q out, Q in and Q out. We have Q from above. These are, yep. Yeah, we should be good. So now we can use solve IVP. I forget what all of the inputs are. Functions first, so we can do right hand side. Our span would be from 0 to T. We'll call it T end. Not to confuse ourselves later. I forget what that one is, but then our method equal rod Q. One sec. So we have 0 to end, and then this one would be our T naught and H naught. H naught, which should be defined somewhere. Here they are. And then the next method is rod. Yeah. And then we also are looking for dense input, I believe was the other one. And that we want to equal false. HW1. Errors. What would coding be without errors? Is everything running good? So now we have to get to the coding of it, which is going to take me a second because I forgot how to do that. So I'll be right back. Okay, here we go. So we have from flatly subplots import makes subplots. Ooh. Well, that would be good. Then down here we have to make subplots. Which this is gonna take a second again. I really should have taken the time. Okay. So to plot we need our x-axis. And then we're going to plot one for temperature, one for height. So we'll need total 2 subplots. And what else? I think that's it. So we need equal and space 10. Need a figure equal. Does it make subplots column one by 2? I remember, and then it's fig add dot add. So it's flat. Because then I can make the first one's x, so it'd be t plot, comma t plot. And then you'd have fig dot add h plot, nope, t plot, h plot. I didn't make them scatter plots. I think that's what is causing the problem. We'll see. No. Not the problem. I have to label these as X and Y. Not coal. Okay, so the first mistake that I have found is this needs to be true. Okay, so now they're on the same plot. We would like them on two separate plots. So in order to do that, row 1, column 1, and this I believe is row 1, column, oops, which I believe will split them. But we're not seeing the oscillating feature that we want. So that due to a too low of time? No. Okay. We have one more second to look. I believe I found the last thing that I messed up, which was I swapped these here. Well, I swapped them down here, which makes me just need to swap them here. And we should see that oscillating function down here. This one looks correct. This one I believe is wrong, if I remember. Let me take a look to see if that is correct. So I'd found my last issue, which was here, and my T0 equation, I missed multiplying by T and not. So that should now fix the graph, and we have both graphs isolating, which makes sense because the temperature should start up but then oscillate down to where we want it, while our height continues to oscillate up and down, following right around the same value once it gets moving.